Hello everyone, welcome back. So as I mentioned at the end of the previous video, we'll now focus on this part of our overall architecture. At this stage, our goal is very clear. We need a mechanism where a user can ask a question. That question is semantically searched against our vector database. The most relevant results are passed to the language model. And finally, an answer is generated for the user. This is exactly what we'll be building in this video. Let's break this down in a simple way. There are 3 steps we need to implement here. First, we need to capture the user's question. Second, we need to perform a similarity or semantic search using that question. And third, we need to generate and display the final answer. Let's begin writing code step by step. As usual, I'll write the code first and then I'll explain you what each part is doing. Let's first step is getting the user's question. Think about it in this way. A user opens an application, whether it's a Streamlit application, a chatbot interface or something similar. We need a way for them to type in a question. Without a question, there's nothing for our system to answer. So, the very first thing is we need an input mechanism. Since we are building a web interface and using Streamlit, we can easily do this by one of the Streamlit's inbuilt functionality. We'll use st.textInput. What this function does is create a text box on the screen where a user can type anything they want. To make it clear, we'll add a placeholder typing like type your question here so the user knows exactly what to do. Once the user enters a question, we store it in a variable. Let's call the variable user_question. Now, whatever the user types into the text box, it gets stored in a variable. And we use it for all the process that follows: similarity search, document retrieval, and answer generation. Now, let's move on to the similarity search. Before writing the code, let's think about what's actually happening here. A similarity search is essentially a comparison. You have 2 things. You are trying to find how closely they match. One side you have your user's question, on the other side you have our vector database. Our job is to compare the question against the content of the vector store and figure out which pieces of the text are most relevant. We have user's question stored in user_question. We have our vector store which contains embedding of our document chunks. When we perform similarity search, we are asking the system, given this question, which chunk in the vector database are closest match. That's why we call vector store.similarity search and pass user_question. This operation returns a set of matching chunks. Depending on the question and the document, it might return 5 chunks, 10 chunks, or sometimes even none. For example, if the question is what is the color of an apple, the vector search might return chunks mentioning red apple, green apple, or so on. We store the results in our variable called match. So now, match contains a list of document chunks that are most relevant to user's question. At this point, let's quickly visualize what's happening. To understand it better, we can temporarily print these matched chunks on Streamlit interface using st.write and pass match in it. Now, let's go ahead and run the application. Once Streamlit reloads, you will see a text input box on the screen. This is the one which we created earlier. If I type who can be the president of India and press enter, what's happening internally is very important to understand. First, the user's question is converted into an embedding. Just like documents, questions are also text and machines don't understand raw text. They understand numbers. So, the question is converted into numerical vector. Once that is done, a semantic similarity search is performed between the question's embedding and the embedding store in the vector store. Based on this comparison, the system identifies the most relevant chunks from the document. As you can see, It might return 4 chunks, 5 chunks that it believes are closest to the related question. So now we have relevant chunks, but still need to generate a proper answer for the user. There is where chaining comes in. A chain is essentially a sequence of steps that happen one after the other. In our case, those steps are: take the user question, retrieve the relevant documents, pass both the language model, and then generate a final answer. That entire flow is what we refer it as a chain. LangChain provides a very relevant way to build this type of question answering flow. So, we import the required package for question answering chains. From LangChain.chains.question answering, import load underscore QA underscore chain. Once that imported, now we'll go ahead and create the chain. So before starting the code, we'll keep the code aligned with the if condition. So let's do it. So we'll go and write load underscore QA underscore chain. We create a chain by specifying two things: the LangChain model we want to use, the type of chain. In our case, the type is stuff. You don't need to worry too much about what stuff means internally. Conceptually, it means take all the relevant documents, bundle them up, and pass them as a context to the language model in one go. We'll store this in a variable called chain. Next, we define our language model. We are using OpenAI here, so let's go ahead and import it. So we'll go on the top and we'll import from LangChain underscore community dot chat models, import chat OpenAI. This is what we will import. So we'll go down and start defining LLM. So let's start writing the code. We write an instance of chat model and passing a few parameters here. The first most important parameter is authentication, your OpenAI API key. Without this, the model won't work. Next comes the temperature parameter. This controls how random or deterministic the model's responses are. A lower temperature like 0 or 0.1 makes the model more focused and precise. A higher temperature allows more creativity and variation, but it can also make responses longer or less relevant. Then we define the maximum number of tokens. This controls how long the response can be. For example, a value of 1000 roughly translates a few hundred words. Finally, we specify the model name. This could be ChatGPT 3.5, GPT-4 or any other model. The exact choice depends on your use case, cost consideration and accuracy requirements. None of these values are fixed. Parameter tuning is an iterative process. You try a value, observe the output, tweak it, and repeat until you are satisfied. Once the LangChain model is defined, we are ready to run the chain. To run the chain, we have to write chain.run and pass two parameters. These parameters are user's question, which is stored in users underscore question variable. So we'll pass that. And then we pass the input documents, which is stored in the match variable. We pass both into the chain, execute it, and store the result in a variable called response. Finally, we display this response on the Streamlit interface by using st.write and passing response in it. Let's first comment this out. We no longer need to print the match chunks. At this point, the entire flow is complete. We refresh the Streamlit app, enter a question again, and let the system process it. Let's write the same question again, that is, who can be the President of India, and see what we get this time. And as you can see, the answer appears. The most important thing to understand over here is that this answer is not coming from internet or not from models pre-training alone. It's generated specifically from the document we provided, in this case the Constitution of India. This means the chatbot is answering questions based on our own custom data. That's the real power. And now let's try some more questions like what's the age for right for education? And press enter. Now let's wait for the OpenAI LLM to generate the answer. So the answer is generated and you can see the age is between 6 to 14 years. Now let's try another question. Can you summarize the process of election of the President of India? And here you get answer by using OpenAI LLM within seconds. And this answer may vary a bit for you and for me because LLM generates answer. It doesn't copy paste or get it from the internet. So we have successfully created a chatbot that can answer questions from our documents. If you are working in an organization with financial documents, legal files, research papers, or internal data, you can build a system that answers questions strictly based on those documents. Another key point is that this is generative AI. The model isn't simply copying text from the document, it's understanding the content, reasoning over it, and generating a fresh response based on the understanding. You can try more questions, summaries, explanations, or procedural questions, and you will see the answers may vary slightly each time. That's normal. Small variations are expected, especially when the parameters like temperature or token limits change. This entire pipeline, embedding, retrieval, fine-tuning via parameters, and generation comes together beautifully here. And the best part, all of this is done roughly in 50 to 60 lines of code. Think about the potential. Students, lawyers, journalists, researchers, anyone can upload documents and start asking questions without reading hundreds of pages manually. This is why generative AI is truly transformative. So, take this code, experiment with it, try a different document, tweak the parameters, and explore possibilities. Just make sure you start with small PDFs so you don't burn out your API credits too soon. With that, we have completed the practical implementation of our chatbot. Spend some time playing with it, and once you are comfortable, we'll move on to the next topic in our upcoming video. Thanks for watching.